what I was saying, we will do this thing, recommendation engine today. So I will just open a WordPad to make our understanding about the recommendation systems. Okay guys. So we will see what are the recommendation systems and what are the types here available in this Mahout. So if you will see this recommendation system broadly, we can divide into the two parts. One is collaboration filtering and other one is content based filtering. So I will type that. And other one is a content based filtering. Okay, so now the first thing I would like to clear here, in the Mahout only collaboration filtering is available. Content based filtering, you on the top of that collaboration filtering you can create. Okay, so now the thing is, what is the part of the collaboration filtering? So inside this we have we can actually divide it in the two way. One is user based recommendation, which little bit yesterday also we were discussing about the recommendations. So what is user based recommendation? User based, and other one is the item based. Okay, so in this collaboration filtering, which is available in the Mahout, we have user based and item based recommendations. So now first we will make our understanding what is this user based recommendation and what is this item based understanding. Then I will define little bit about content based filtering also, what it is and how it works. Okay, so let's see, first example we will see in the user based filtering. Okay, so now let's see, I have some users and I have certain books with me, okay, which these users are liking. So let's, okay, so Rohit, this question is, do we need a Spark for recommendation in this engine understanding? Rohit, actually, as yesterday also we mentioned that Spark also provides some of the machine learning algorithms. So as of now for this course, no, you don't need that Spark recommendation engine, but we are including one chapter of this Spark thing because it is also catching up in the market. So just to give a glimpse that okay, what are the machine learning algorithms available there, we can look into that. But for this particular course, because we are concentrating on the Mahout only, so we will just use the Mahout thing only. Is that answer your question, Rohit? Okay, so fine. I was saying I have a list of users and a list of books. So let's say in the user side, let's say we have Rohit, and who actually likes the book Hadoop. Let's say some book name is there. Let's say that definitive guide only there. Okay, fine. And one more book which he likes, I would say, let's say, for example, Mahout in action. Okay, and let's say add one more here. So I would add Hadoop in action. I'm just randomly writing the name. It can happen that these books are not there, but just for our understanding purpose, I'm telling this thing. Okay, so let's say, and then we have there on, we find out that Uday is also liking the book Hadoop. is there for him. Not open action. Okay, now, and let's say we are having in our list, I'm just writing down the list, a username you can understand anyone. I'm just writing some of the book name here again. Let's say we are having some book called Mahout cookbook, and I'm again saying it's a disclaimer, these books can be or cannot be there. I'm just writing for the understanding. And let's say we have a book called Hadoop and Mahout. Fine. And we can have other users also. Let's say we have we have Amit is also there, and we have Prashant also there, right? So now first we will discuss about what is this user-based recommendation. So in the user-based recommendation, we will try to find out a relation between two users' likings, and then based on that liking we will try to recommend a product or a item to that particular user. So let's say here in this example we can see that Rohit likes a book called Hadoop Definitive Guide. Uday also like that, and Rohit also likes two other books also in which Hadoop in action is also the one. In the same way, if you will see the list, Uday also likes the book which is Hadoop in action. So now we can find out, and let's say they have given the approximately same ratings to both the books. So we can find out a similarity in these users' likings. So in this scenario, we can recommend a book to Uday, Mahout in action, which Rohit already liked. So we can find out a correlation because both users' liking are actually same. So it can happen that Uday will also like a book called Mahout in action, which Rohit liked. So it is called a user-based recommendation, where based on the user likings, we are recommending a particular product to other user. And this is already there. This user-based recommendation is there in the Mahout, and we will take up today one example based on that user-based thing. And yesterday actually Uday asked me one question regarding the similarity matrix formulas we were discussing yesterday. So he was saying that where we will use this, and also one of the formula we will use in this user-based recommendation thing. An example we will use today, so that I will explain there. So now this is user-based recommendation. So coming to the item-based recommendation. So in the item-based, what we will trying to do, we will find a correlation between the items itself. That if a user is liking certain items, so what other items he can like. So in this case, if you will see, let's say for an example, for the user Uday, we are now doing the item-based recommendation, and we find out that he is liking a book called Hadoop Definitive Guide, and also he is liking a book Hadoop in action. So if we will talk about the item-based recommendation, then there is a more probability that a recommendation engine will suggest a book called Hadoop and Mahout for this user Uday, because in the item side he find out that these items can have the similarity, which is this Hadoop. So instead of giving a other book like Mahout in action or other offer like Mahout cookbook, the system will recommend him a book called Hadoop and Mahout because of its item similarity more from the Hadoop Definitive Guide and Hadoop in action. This is called the item-based recommendation, and it is I would say when we will implement in the Mahout side, it is actually same as the user-based recommendation. Little bit of the similarity matrix and all those things we will have to change accordingly. So this is what the item-based recommendation says. Now coming to the third type, which I was saying it is not there already implemented in the Mahout, but on the top of user and item-based recommendations we can implement that, and generally this is what other people also does, and this content based filtering is actually not that useful also. So in the content based filtering, what happened, we provide the recommendation based on the contents. So let's say an example, we find out that a other user called Amit, he likes the books which is of, whatever books he likes as of now, we find out that they are about the same author. Let's say Tom White is the author and he is liking all his book. So this will be part of the content base. So next book which we will try to recommend, if we are using the content based filtering, we will provide him a recommendation for the same author. So which is called a content based filtering. In this case, let's say for some particular, we were finding out that Prashant is using the books which are having only 100 to 150 pages. So we will try to recommend him a next book which is of that, means which is fulfilling that criteria of the author type and the page wise and all. So what we are actually doing, we are looking at the content of the item and then we are recommending. So it is called a content based filtering here. So any questions guys here, or is it clear? Okay. So what I will do, I will move to the slide a little bit. So this is what recommendation says. So recommendation takes user behavior and from that tries to find out user might like. So obviously it is like, if you will see, it is like predicting the unknown thing. You are not sure whether you will like or not. Okay, so Rohit is having a question. In this case of user based recording, there are chances of going to another domain. Okay, Rohit, yeah, you can say, means another domain wise, you can say the products and all. Yes, that is also possible. Like let's say instead of book, you are also liking the music and all. So that also can be provided. It is like we are just saying user and items. That item could be anything. Means if we will find out the similarity of your choices, let's say you are finding out the musics also, you are buying from the Amazon Music also, and we find out that other guy is also having the same interest or provide the same ratings on the music side, which whatever you provided. So the recommendation is try to provide that also, that recommendation to that user also. So it is not like stick to this one, but in that one particular context, item wise, if you will see generally in all the e-commerce site or this one, it would be like related only. Like if someone is searching for the books, so that particular recommendation only will come into picture. That okay, the other people who are having the same interest in the books, something like that. Okay. So I was telling you this in this recommendation. Actually, the real question is how much you will like every possible item that you have not yet seen or expressed any preference to that. So that is actually that is the duty of the recommendation engine, to recommend a particular thing to a user which he till now he didn't explore, and or you can say he is not aware, but still we are recommending him in the best possible way. That should be the criteria of a good recommendation engine. So if you will see this in this slide also, it is saying broadly speaking, we can build a recommender either by finding question that a user may be interested in answering, based on the question answered by other user like him, finding other questions that are similar to questions he answered already. So okay, this is question bit, but you can see generally how we will recommend by the ratings and all. So we will ask user to provide the ratings to particular product, and based on that only we will generally recommend the things. And there are way without the ratings also, and these things actually third column is like I will go back here. Generally I just say that okay, user and books, and there would be a ratings also, preference value. It can be there, it cannot be there. We will discuss that also, which is called a preference value, that if it is not there, then how to recommend a particular thing to a user. Okay, so if you will see the recommendation algorithms which are there in the Mahout side, user-based collaborative filtering and item-based collaborative filtering. Slope one recommenders also is there. We will discuss that also, and then singular value decomposition. So as we progress, we will see these two type of recommendations also here. So here, what I will do now, I will try to showcase you one of the user-based collaborative filtering example in the Mahout, and what are the classes are there, or what are the interfaces are there which we will use to create that. So before that, just a little bit of more theoretical thing. So Mahout implements a collaborative filtering framework. As I was saying, it is both user-based and item-based, and this type of filtering is very much popular in the e-commerce side, like Amazon. So how they track the historical data by the ratings which user generally provides there, or clicks and purchases to provide the recommendation. So why this clicks is there, if you will see, if you will visit this type of sites once, and second time if you are coming, they will also show that last time you visited this thing and all. So they knows that okay, wherever you are clicking and all, so they are storing that data also with them. So again, user-based recommended item by finding similar users. This is often harder to scale because of the dynamic nature of the users, obviously, because of the finding of the similarity between users. Right now we took up the example of only 2 users, but there could be many, and then filtering out to the right level is really a challenge there. And then second is our item-based, in which what we do, we find out the similarity between the items and make recommendations. So, and obviously item usually don't change that much. At user one, you can see the real-time things, dynamic. A user can visit at its site anytime, and the item is like provided by the service provider. They only will put those items in their sites and all, obviously. And in the slope one, if you will see, it's a very fast and simple item-based recommendation approach. Same way, means approach would be same, only this one of the class will change. I will tell you which class, and it is actually applicable when user have given rating and not just the Boolean preference, means not just like like or dislike, that thing is not there, but if actual ratings are there, that okay, if you are buying some of the let's say books, you are giving rating that okay, out of 5 I like this book, 4 star or 3 stars, something like that will happen. Okay. So moving to the other slide. So this is the main interest for us. I will just give a little halt also to this slide. So the Mahout implements interfaces to these abstractions. So when we are actually write our recommendation engine using Mahout, so what are the steps we will have to follow? So if you will see, first thing is the data model. Data model is nothing but to provide data in a way so that Mahout can understand. In a simple term, I am saying this is called a data model, and there is a interface is there, data model, where we will provide our input file. It could be CSV format, it could be tab format and all, and this data model will only take care to tell the Mahout that okay, this is the input. Now after that, there would be other two things. One is user similarity and item similarity. These things I would say these are equal. So in your recommendation engine, if you are providing the user based recommendation, there would be user similarity class, and if you are providing the item based, it would be item based class. And then after, means based on that thing, you will provide, and these are actually like to calculate the degree of the correlation between the users, if you are providing a user similarity, or between the items, that okay, how two items are close to each other, that. And then there is after this there is the user neighborhood, and in the similarity, actually in the simple terms, it tells that how similar these two users or two items are. This is the similarity. And user neighborhood, after that similarity, we will write the code for the user neighborhood. What user neighborhood is? It is the group of users most similar to the given user. Okay, so in the similarity we are finding out the similar users. In the neighborhood we are just finding out a group of users which could be the similar to that particular user. And then generally we use this n neighborhood concept there. So what it does, it actually takes 3 parameters inside that. It will take up the similarity, neighborhood size, means okay how many neighbors, close neighbors you will select, 2, 3, 4, and then similarity, whatever similarity you will select in the code, and then your data model. It will take those things. Okay, and then in the last step would be the your recommender, means main recommendation engine. Based on these inputs it will recommend you something. Something means it could be the user one, or it could be the item based one. So main job of the recommender is to collect all this data in one place and then show you the output. So what I will do quickly, I will go through my different system which will actually show you one of the program. It's just a sample program. So we will discuss about the input, that okay what input it is taking, and then we will see that what are the methods we used in the particular Mahout program, and then we will try to get a user based recommendation for a particular user. Okay, so let me open the other system as of now. So generally idea is we have make up a sample input where and one more thing actually before that it is opening, I would like to explain one more thing. Mahout or whatever, let's say you are working with traditional database systems also, you will find out that whenever you will save some users or some products and all, you will assign some IDs to that also. And if you will notice, based on those IDs only we will actually work. So in the Mahout recommendation system also, generally how we will provide this preference thing, it is like there would be a user ID. Then a user ID means like instead of defining directly the users, we will assign an associate ID with those users. Like in our example, I was taking the Rohit, Amit, Uday and Prashant as a users. So what would happen, there would be a user ID assigned to them. Same goes with the product also, there would be a product ID and then corresponding ratings of that. So first we will see how the input looks like in this particular example. So this is just a very small input. So if you will see here, this is how if any of the file, generally you will find out this is the way it will go into the recommendation system. So first column, this column is for the user IDs. We will define just for the example. It could be very complex also, like in our traditional database systems. And second column is your product ID. We are providing some of the product ID. And third column is the preference, or I would say ratings, which you are providing for that particular product. So here if you will see, we have 3 products for the user 1, 101, 102, 103 and different rating for that. Same goes with the user 2. He also provides some of the ratings for some other products. So you can correlate these products as a book or as a movie or whatever you like. But in the real-time system, the data will go in this numeric format only. So there would be, obviously there would be a table which will map this user ID to name. So in the end, when you will show the result to the user, that will be converted. And that's how the all the systems works. So now the thing would be, based on this data, we will try to find out a relation between the users, and based on that users, we will try to recommend a product for a particular user, which you can define in your method. So this is the input thing. Okay, it's a comma separated file. Okay, Uday says what is the third and fourth column? So Uday, actually there are, if you will see, there are only 3 columns. I'm just highlighting this. First is the user ID 5. Second is the product ID, let's say 106. Third one is a float variable, which is a rating like 4.0, 3.5, right? So it's only 3 columns. So I will show you one later point of time, one more example with the real-time data, which is like movie ratings and all. So that data is also similar to this format. Like there would be a user ID, product ID, and then particular rating. Okay, so this is about the input data. So, and if you will see the actual class, so what is happening, we will one by one we will explain all the methods here. So as I told you, there are 4 things. Model, if you will see, data model is there. Similarity, because we are right now I'm working on the user based recommendation, so it is a similarity, user similarity is there, that class or interface you can say. We will check it out as of now. And then there is a user neighborhood as explained in the slide, and then there is a actually recommender engine which will take all these parameters, model, neighborhood and similarity, and it will try to recommend a product, only one product, for a user whose ID is 1. Fine. This is the program intention. We are providing a input file to this as a model. Data model is the one which will take care to provide this file to the Mahout system, and then we are having a similarity, user similarity class, which will try to find out the similarity. So now here comes the Uday's question, which yesterday he asked about the similarity matrix and all. So in this particular scenario, we are using this Pearson correlation similarity. So now you guys would be thinking what it is, and because yesterday we didn't cover, so a little bit about this Pearson correlation similarity I would like to define. So what it stands for and all. So if you will see in the Pearson correlation similarity, what we are having, let's say we are having 2 users, okay, and they are providing some of the ratings, which we called in terms of this recommendation, we called as a preference value. Okay, so we are providing some preference value. So what we will do for a user, let's say user A, we will try to find out sum of A, which is what it is. It is sum of the square of all A's preference values. Means let's say our user A is Rohit. So whatever for the items Rohit is providing ratings, we will square those ratings and sum it up. Okay, all the for all the products. So let's say for an example, he provided these type of ratings, 4.0 and then 3.0 and then here it is 2.0. Fine. So what would be the sum of these preference values is like simple terms I would say 4 square. So I would say here 4 into 4 plus 3 into 3 plus 2 into 2. So we will calculate first sum of A, means for one particular user. Same way, let's say we have other user also, for all his preference value we will calculate sum B. Okay, in the same way. Then we will calculate sum AB. What it is? It is like sum of the product of A's and B's preference value for all the items for which A and B express preferences. Now, if in the case of our earlier example, like Rohit and Uday case, so we will find out that if as of now there are 2 products similar, this Hadoop definitive guide and Hadoop in action. So let's say he provided rating for this 5.0 and for this particular Hadoop in action he is providing 4.5 rating. So these 2 ratings are only common. So in sum of AB it would be like 5 into 4 for the Hadoop definitive guide the rating of the user B and the user A plus other product of the other rating. So this is the other one which is matching 4.5 into 3. This would be the sum AB. Okay, and then finally how we will calculate that similarity formula correlation. It would be sum of AB divided by square root of sum of A into sum of B. Into sum of P. So this would be that's how this similarity will work. So if you remember yesterday we saw a lot of like Euclidean distance formula where we were just subtracting and squaring and then finding out the square root, or we saw the cosine distance formula and all those things. So in that term only, this how this Pearson similarity matrix work. This is how it works. Okay. So now coming back to our question. Okay, so now this if you will see user neighborhood, what it is doing, user neighborhood it is taking. So here if you will see 3 parameters we are passing here. One, this model is obviously the same model, the input one. Similarity, whatever similarity matrix you are using, here we are using Pearson correlation similarity, and the first parameter is nothing but the neighborhood number. So we are just interested in the 2, like 2 closely neighbors. We are interested for that particular user. Okay, then we are using a recommender which is a generic user based recommender. I will cover that. There are a lot of recommenders also, different recommender which they are having different properties in that. So in that one, generic user based recommender is one of them. I will explain that. So it is again taking 3 parameters of your data model, your neighborhood and your similarity, and based on that it will actually then it is having a method called recommend which will take your input for the user and what product you will define to him. So if we will go back to this particular input text, we will find out some of the correlations between the users and their item. So if you will notice, just notice the user 1 and user 5. User 1 which is having product 101, 102 and 103, and user 5 which is having a lot of list, and it is also having 101, 102 and 103. So let's see, for the user 1 and 5 both have provided for 101 approximately high rating 5, and 5 is providing 4. For 102 same rating. For 103 1 is providing 2.5 and 5 is providing 2. So we can say in terms of our recommendation that yes, they could be similar sort of taste wise. Same goes with the user 1 and 4 also. So if you will see the 4 also, it is also providing for the 1015 rating, and 103 it is also providing 3 rating, where 1 is providing 2.5 rating. And you can find out other differences also, that okay, user 1, what is the relation between user 1 and user 2, and what is the relation between user 2 and 3, these things. So based on these calculations, that okay, who is close to this similarity and what rating should provide, so our recommendation engine will recommend a particular item, one product, to the one user. So let's see what it will provide. So one more thing, as I yesterday also I told, these programs would be like a simple Java based. Once you will integrate all the ZARs and other things into your system, it would be very easy, and just a simple Java run as a Java application, it will work. So let's see what output it is providing to us. So okay, this recommendation is run. So if you will see the information also, it provides processed 5 users and recommended item 104, and actually it will try to predict the preference value also, which if you will see that product which you will provide. You got the last point, that for this user, okay, Rohit says is that recommender 1 is user ID and the product ID. It is like, Rohit, it is like for the user 1, give me one product. Okay, for the user one, which is user ID, other one is the numeric number that I want one thing. So if you will see in this particular case, what they did, they have provided for the user one that okay, based on the other neighbors and all similarity, item 104 he will like, and if you will see in the list, let me just make it bigger. In the list there is no 104 as of now for the user one. Okay, and one more positive thing which system is doing, it is also providing a preference value also. It is predicting that also, that okay, if user will take 104, this could be his preference value. Obviously behind the scene there is a lot of calculation is going on, and we are having a very small data in that one. Okay, still manually also we will go, we can find out, but in the real terms when there is a huge data, it is really useful, these type of algorithms to understand. So okay, so let's see again some of the slides. We will see. Rohit asking the value is a preference or probability of the similarity. As of now, I would say it is a preference, which obviously it is a probability sort of thing. So system is saying this could be the value which user will provide for this particular item. Okay, so Kaushik is having something. Is user-based recommendation pre-computed on the site like Amazon, or are they computed in real time? Okay, so Kaushik, it is like a real time also. If you will see real time also, it will happen in the real time scenario. Okay, so Bhushan is asking for which user item 10404 is recommended. So Bhushan, it is for user one. If you will see, I told you, recommender or recommend the items which we pass is 11. So it is for the user one. So coming back to, okay, if I want to know who are probable users for a product, it is covered in item based filtering. So it is what to know what are the probable users for a particular product. No, actually if you will see it would be like what you are trying to say, one particular product, who are the users who like that particular product. It would still be a user based, and that's how you will find out the similarity between the users. And in between there is one more Rohit question is there. What if there are no ratings? How would the system? Yes, Rohit, we will cover that also. So if there is no rating, how the system will deal with this? And there are scenarios where actually ratings are not required, still we wanted to recommend something. So in the later point of the slides, we have that scenario also, that there is no rating, or we wanted to delete some of the ratings to recommend something else. I will cover that today only, that thing. Because don't think that these are the only classes, like in the similarity wise we just use here Pearson correlation similarity. So don't think these are the only one available in the system. There are a lot. If you will go to the APIs and all, there are lots and lots of that. So in this particular example we use this one. So when we will go back to the Rohit question, which he is saying that no ratings are provided, then we will use other one. That how the system will deal with that. And actually I have that one sample for that sample program for the real data plus without preference value also. And one more thing I would like to tell you here, there could be chances that okay, preference values are there in the data, but I want to ignore. So that cases are also there, and why we will ignore and how to do that, I will tell you that thing also. Okay, so sorry about this. Go back to our this one. So we covered this thing, that okay, data model, how this will work. User similarity also we saw in this particular example. We use Pearson correlation similarity, and then user neighborhood, where we will pass the similarity and model, and then what would be the neighborhood we are looking, and then the all recommender. Right now we use general user based recommender. There are others also. So let's move to the other slide. So as I was telling you, there are other recommendations engines also. They are having their own what you say features and or things, and based on your real-time scenarios and all, you will choose one of them. So one is like general user-based recommendation. So key parameters are here: user similarity matrix and neighborhood definition and size. So if you will see, we have already saw this neighborhood definition wise the Pearson correlation similarity, and then two neighbors we were taking care. And what are the key features here is the conventional implementation, and first when number of users is relatively small. Okay, and I think it's in generally it is not very much used because whenever e-commerce site and all, if you will see that we are having a lot of users in the data, so they are actually in that real-time scenarios hardly it is used. And second is the generic item based recommender. If you will see it's the same, but it will look into the item similarity matrix. And it is also fast when the number of items is relatively small, and useful when an external notion of item similarity is available. So external notion means there would be one more factor would be given there, that where we can find out that okay how this product is similar to that. It could be the type of the product, like okay this is related to the books, it is related to the music and all. So some external factor would be there. Okay, Bhushan says, can we say that recommendation is a part of collaborative filtering? Yes, Bhushan, if you notice the how I started, I said recommendation, there are two type of recommendation: collaborative filtering and item based content based filtering. If you will go, I will go to this. So that's how I started. So recommendation system is having collaborative filtering, in which user based and item based will come into picture broadly, and then we are having a content based filtering also, which is generally not used, and we can build it on the top of user and item based this thing. Okay, so going back to the slide, so other one is a recommender engine. If you will see, we are having the slope one recommender, which is having a different storage strategy, and recommendations and updates are fast at runtime, requires large recomputation, and suitable when number of items is relatively small again. And there is again called a SVD recommender also. So key parameters are it's having a number of features which it will take, and good results required large pre-computation before giving you the result. There is a lot of calculation will go in behind the scenes. So if moving to the next slide, there are other types of engines also, like key and item based recommendation, number of mean K, item similarity matrix, and neighborhood size it will take care. And actually we will find out more these type of engine when we will program and when you use. So in that scenario only it would be more useful, these type of information. Right now just for the theoretical purpose, you will understand that okay this is like item based recommender, so I will use in the item based and all. So but in the real time they have their different pros and cons. So if this tree clustering recommended there is something called a cluster based recommendation also, which we will cover in the next class of the recommendation. If you notice, we have two classes for the recommendation thing. So in the next one we will define this number of clusters, and its key parameters of this tree clustering recommender is cluster similarity definitions and user similarity matrix. And it is a fast at runtime, requires large pre-computation, good when number of users is relatively small. So whatever we listed here as of now is good when the numbers are small, but there are engines also available which are very good when the users or items are really large. And at that time only this power of Mahout come into picture, because if you are having a huge amount of the data and all, so behind the scenes you can use Hadoop to handle that data and go ahead with that. Okay, so moving to this next slide, as I think someone has asked about this thing also, like Amazon they asked real time or how they use. So as I was telling you, there is the real time scenarios also where companies use for the recommendation. So as soon as you will provide the data, they will take it up, and how this real time thing happen you can do in the Mahout also. In the next slides I will cover that also. There is something called refresh method, that how to take up the new inputs into your input file. So as of now here the famous engines for the recommendation, obviously Amazon, I think everyone of us knows about this, and Netflix. Social networking site like Facebook, as yesterday also I was defining the Facebook site. If you will go and you will see in the right hand side there would be some ads, and it is not like it is not a static that okay whoever will open it will be for same for everyone. It based on your liking and disliking, or with your with it depends on this thing also, that you are commenting on one particular friend very much and that friend also commenting on your thoughts or your photos very much. So based on his liking or your liking, a recommendation will be given to him or you. So it is like that type of recommendation is also there. And then clustering engine, if you see Google News, if how the Google cluster out the news. So this example yesterday also we took it out, that news which are similar interest will be clustered together. And like topic wise, it could be like political news, all the political news, or one topic wise, like recently this MH370 case was going on, so all the news related to that particular article will be clustered together. So that type of thing is already there. And then classification engines, obviously spam emails is the huge one which Yahoo is having, and basically Yahoo for this spam detection and all behind the scenes Hadoop technology is used in the Yahoo, and they have more than 10,000 I think now cluster for that. Picasa also classified the photos and all, and obviously Apple's genuine features in the iTunes and all, so they are also a part of the classification.